So for today, we're going to discuss about sequences. So this is Sir Topper. Many situations in the fields of sciences and mathematics involve numbers arranged in definite order or sequences related to each other, such as minutes in an hour, successive powers of 10, squares of integers, and others. Can you find the sum of the first 100 positive integers? 1 plus 2 plus 3 plus ... plus 98 plus 99 plus 100 without paper and pencil. A great mathematician, Carl Friedrich Gauss, 1777 to 1885, then a schoolboy was asked to find the sum of the first 100 positive integers. 1 plus 2 plus 3 plus 98 plus 99 plus 100. Without paper and pencil, this is how he reasoned out. So he added 1 plus 100, 2 plus 99, 3 plus 98, and he found out that it is equal to 101. So let's have the meaning of sequence. A sequence or a progression is a set of numbers written in a special order by the application of a definite rule. Each number in the sequence is called the term. The first number is called the first term, followed by the second term, third term, and so on. Let's have the examples. 1, 4, 9, 16, 25. 2, 4, 6, 8, 10. 3, 7, 11, 15, 19, and so on. For number 1, every term is obtained by squaring counting numbers from 1 to 5. We have 1 squared, 2 squared, 4, 3 squared, 9, 4 squared, 16, and 5 squared, 25. And for number 2, every term after the first is obtained by adding 2 to the preceding one. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, and so on and so forth. Let's have the third one. Every term after the first is obtained by adding 4 to the preceding one. Let's check. 3 plus 4 is 7, plus 4, 11, plus 4, 15, plus 4, 19, and so on and so forth. So let's have the terms in a sequence. A sequence may be finite or infinite, depending on its terms. It is said to be finite if it has first term and the last term. Examples. Number 1, 1, 3, 5, 9, 11. The first term here is 1 and the last term is 11. Number 2, 1 half, 1 third, 1 fourth, 1 fifth, 1 sixth. The first term is 1 half and the last term is 1 sixth. A sequence is said to be infinite if it has the first term but no last term, and that is, it is endless. Examples. Number 1, 3, 6, 9, 12, 15 to 3n. Number 2, 2, 6, 12, 20 to n times the quantity n plus 1. So let's have the concept. A sequence is the range of a function whose domain is either the subset of or the set of positive integers. Subscripts are used to designate the number of a term. It is customary to use a sub 1, a sub 2, a sub 3 to a sub n to designate a sequence of n terms. To avoid any misunderstanding about ordering, the nth term or a sub n of a sequence is designated by an algebraic algebra. Examples. Write the first four terms of a sequence y equals 3x minus 2. Solution. Y equals 3x minus 2 may be written as a sub n equals 3n minus 2, where a sub 1 is 3 times 1, minus 2 is 3 minus 2 equals 1. Where n is 2, we have 3 times 2 minus 2, which is 6 minus 2 equals 4. For a sub 3, where n is 3, we have 3 times 3, 9, minus 2 is 7. And for a sub 4, where n is 4, it is 3 times 4, 12, minus 2 is 10. The first four terms are 1, 4, 7, and 10. Using the given sequence, what is the 10th term? In this case, we just replace the value of n to 10. So we have a sub 10 equals 3 times 10 minus 2, which is 30 minus 2 equals 28. Rules for generating a sequence. Since a sequence is a function on the subject of natural numbers, it can be described by an equation. The first terms are given, from which the rule is determined and then translated into an equation. Examples. Discover the equation of the sequence by looking at the pattern. Number 1, 4, 5, 6, 7. So let's see. A sub 1 is 4, so it is 3 plus 1. A sub 2 is 5, so 3 plus 2. A sub 3 is 6, we have 3 plus 3. And A sub 4 is 3 plus 4, which is 7. So from this, we can have the general equation. The equation is A sub n equals n plus 3. So n can be any number, then added by 3. So let's have number 2 example. You have 1/2, 2/3, 3/4, 4/5, and 5/6. So let's have the solution. Let's have a sub 1 equals 1 all over 1 plus 1, which is equal to 1/2. A sub 2 is 2 all over 2 plus 1 equals 2/3. A sub 3 is 3 all over 3 plus 1 equals 3/4. And A sub 4 is 4 all over 4 plus 1 equals 4/5. Then A sub 5 is 5 all over 5 plus 1, which is 5 over 6. We can have the general equation for this. So let's have it. A sub n equals n all over n plus 1. Can you follow? So let's have some class enhancement. So by following the pattern, write the next 3 terms in a sequence. Number 1, 1, 2, 3, 4, 5, and so on. Number 2, 3, 1, -1, -3, and so on. For number 3, 5, 3, 1, and so on. For letter B, write the first 5 terms of the sequence described by the function y equals 4x, 2, y equals 2x squared, number 3, y equals x times the quantity 2 minus x. And lastly, write the equation that describes the sequence. 1, 1, 3, 5, 7, and so on. 2, -5, -2, 1, 4. And then we have 1/2, 1/4, 1/8, and 1/16, and so on. So I have the seat work. Write the first 4 terms of the sequence with a given rule. Number 1, a sub n equals 2n plus 3. Number 2, a sub n equals 5n plus 6. Number 3, a sub n equals 2 times the quantity n plus 3. Number 4, a sub n equals -n. 5, a sub n equals -2 minus 3. Then we have letter B for our seat work. Write equation describes the sequence. 6, 0, -4, -8, -12. 7, 2, negative 3, negative 8, negative 13. Number 8, 1.6, 1.9, 2.2, 2.5. And number 9, 1, 2, 4, 8. And lastly, 2, 1, 0, negative 1.